AP Calculus 6-8 Part 2, and today we're going to cover anti-differentiation of basic trig functions. So I want you to look at these, review the derivatives of our basic trig function. The derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, derivative of cosecant is negative cosecant cotangent, derivative of secant is secant tangent, and derivative of cotangent is negative cosecant squared. We are going to go backwards with these, so we need to recognize these basic functions, what they are when the derivative has been taken. So if we have the integral of cosine, we're going to end up with sine. The integral of sine would give us a negative cosine, and we're going backwards. So here I've got the antiderivatives written down. So if you look at those, the antiderivative of sine is negative cosine, and you can't forget the plus c. Antiderivative of cosine would be sine. Think backwards. The derivative of sine was cosine. No negatives, so it's going to be regular sine plus c. Antiderivative of secant squared, if you think backwards, the derivative of tangent was secant squared. So if you have a secant squared behind an antiderivative sign, it's going to be tangent plus c. Secant tangent, its derivative, it is the derivative of secant. So antiderivative of secant tangent is secant plus c. Antiderivative of cosecant cotangent would be a negative cosecant. Remember, the derivative of cosecant was a negative cosecant cotangent. And then antiderivative of cosecant squared is a negative cotangent x. So we're going backwards. And remember, you can't forget the plus c's for all of these. That still applies because they may have had a constant added to them before we took the derivative. I'm going to give you a minute to go ahead and copy all of this down. So go ahead and pause the video, copy this in your notes because you're going to need them to refer to. You will need to memorize all of these just as you've memorized all of these. So copy them down and then we'll do some examples. For my first example, I've got a 2 in front of the sine x. Remember from our properties that 2 can be brought out to the front. This is a good example of when it's good to bring that constant out. And then the antiderivative of sine is negative cosine x. So I've got a negative 2 cosine x plus c. Sometimes you're going to have to rewrite using your trig functions. With this one, I don't have anything that is a quotient over here, so I'm going to have to rewrite that to see if I can get it to equal one of these. So I know that this is cosine squared, which is cosine times cosine, so I am allowed to separate that out. And if I do that, I could do, that's the same thing as 1 over cosine x times sine over cosine x. So sine x over cosine x. And I still have the dx. And then I know 1 over cosine is secant x. I know sine over cosine is tangent x. So now I have rewritten that to be one of my antiderivatives. So secant x, antiderivative of secant x tangent x is secant x plus c. So sometimes you'll have to rewrite. Sometimes you might have more than one term. If I have something like that, I can separate that out as the antiderivative of x squared dx minus the antiderivative of cosine x dx, and then do each antiderivative separately. So this would be x cubed over 3 minus antiderivative of cosine is sine. So we've got sine x, we've got a plus c, and the antiderivative of cosine is a positive sign, so we don't need any negatives. So that would be our final answer. And you could write this as 1/3 x cubed if you want, but you don't have to. For this one, I can separate it out. That's the same thing as the antiderivative of 2 cosine x dx plus the antiderivative of 5 sine x dx. I can then bring the whole numbers out. So that's 2 antiderivative of cosine x dx plus 5 times the antiderivative of sine x dx. And certainly if you're able to do that, go straight from here to here, that's fine. You don't have to do it in 2 separate steps. Then this would be 2 antiderivative of cosine is sine. So we've got 2 sine x plus that 5 stays here. Antiderivative of sine is negative cosine. So that's going to be a negative. So I need a minus cosine x. and then the plus c. So these are really pretty simple. The main thing is remembering when you need a negative, when you don't. And remember, it's opposite of what used to be. We used to say that the trig functions that start with a c, their derivatives would need a negative. And that's always how I remember it. I think back to the derivatives and decide, did the original need the negative? If it did, then my antiderivative also needs that negative. Another thing that's going to be important in this lesson is the trig identities. Remember from pre-calculus, your trig identities, sine squared x plus cosine squared x equals 1. 1 plus tangent squared x equals secant squared. 1 plus cotangent squared x equals cosecant squared. You need to commit those to memory as well. Let's pause the video, write that down, and you can use that to refer to these next examples. But for your AP test, you're going to have those memorized. So if I'm trying to do this example, I'm going to see if I can get it to look like any of my original trig derivatives or antiderivatives, and I can't. I can't get this to be a cosine, a sine, or secant tangent, cosecant cotangent, or secant squared or cosecant squared. So I'm going to have to manipulate this using some other trig identities to try to get it to equal one of those things. So here I've got a sine. It kind of stands alone on top. There's really nothing I can do with that. But I notice that this sine is squared. And if this is just one sine, I can't separate that denominator because I've got a plus or a minus here. So you can't separate the denominator. So you're going to have to manipulate it to use one of the trig identities. And if you notice here, this is 1 minus sine squared. If we were to move this sine squared over, wouldn't 1 minus sine squared equal cosine squared? So I'm going to rewrite that as a cosine squared, because 1 minus sine squared x equals cosine squared x. I still have my dx. Now I can separate that one like I did in the last section. That's the same thing as sine x over cosine x times 1 over cosine x. We still have the dx. And so if you think about that, sine over cosine is tangent x, and 1 over cosine is secant x. Isn't one of our antiderivative rules secant x tangent x? The antiderivative of secant x tangent x is secant x. And we do need the plus c. So I was able to use my trig identities to rewrite and then separate it out and then get it to equal one of my original antiderivatives and get my final answer. Okay, looking at this, your first thought might be, well, let's separate it out and let's do the antiderivative of cotangent squared plus antiderivative of 1. Well, if you think about that, there is no antiderivative of cotangent squared. So we're not going to be able to do that. So I'm going to have to rewrite it using my trig identities. Well, that's got cotangent squared and 1. This one has cotangent squared and 1. And that is cotangent squared plus 1. This is cotangent squared plus 1. So this is the same thing as cosecant squared. So the antiderivative of cosecant squared x is actually what they have there. And remember, they could use any variable. They might use theta. They might use t. They could use any variable that they want to. They don't have to always use x. So the antiderivative of cosecant squared is a negative cotangent, and that we need also a plus c. For this one, this is a product. We don't have a product rule for anti-differentiation, so I'm going to have to multiply those together first. So I've got cosecant x cotangent x minus cosecant squared x, and that still has a dx. So if I separate this out, I can say that this is the antiderivative of cosecant x cotangent x, which we have a rule for, and I need the dx, minus the antiderivative of cosecant squared x, and that we have a rule for. So the antiderivative of cosecant cotangent is cosecant x, and that would need a negative. The derivative of cosecant is negative cosecant cotangent. For cosecant squared x, that is the cotangent. The derivative of cotangent x is a negative cosecant cotangent, so I need a negative in front here, so that would make this a plus, and we need a plus c for that one. If you have something like this, you can separate that out as the antiderivative of secant x tangent x, dx plus the antiderivative of dx. Antiderivative of secant x tangent x is a secant x. Antiderivative of dx is just a 1x, and we would have a plus c. So that gives you enough to go with. For your homework, some of them will require you to use trig identities. Some of them are going to require you to take derivatives, and some of them will ask you to take antiderivatives. So you're going to get some practice going both directions, I believe.